In this question, water flows through a circular pipe of varying thickness as shown in the diagram. We're told the inflow pipe, that's this part here, has a cross-sectional area of 0.0523 meters squared. I'm going to draw that on here. The area there is 0.0523 meters squared. And we're told the outflow pipe has a cross-sectional area of 0.0951 meters squared. Again, I'm going to write that on here. The area is 0.0951 meters squared. Then we're asked to complete the chart by determining the cross-sectional area, water velocity, and volume flow rate of both the inflow and the outflow. Okay, so we can see our known values in this question are, for the inflow, we've got the area and the velocity, and for the outflow, we've just got the area. So we're going to be looking to figure out the outflow velocity. Let's start by filling in our known values into our table. So for the inflow, we know the area, we were given that in the question. It's 0.0523 meters squared. For the inflow, we're also given the velocity in the question. It's given here, drawn on the diagram. It's 2.84 meters per second. For the outflow, we know the area, so we can fill that in. It's 0.0951 meters squared. The velocity, we don't know. That's what we're trying to find. We also don't know the volume flow rate for either the inflow or the outflow. So let's head to our reference sheet. And down here we have the continuity equation. It says Q equals AV. Q equals AV. So here, A, that's our area. V, that's our velocity. And Q, that's our volume flow rate. So the volume flow rate is the volume of water that flows past a point every second. So it's like speed or velocity, but it also includes the area. So it's to do with the volume of water going past. To find that, we multiply the area or cross-sectional area of the pipe and the velocity of the water together. So we have Q equals AV. A, the area, is 0.0523 times V, the velocity, is 2.84. When we multiply those together, we get a volume flow rate of 0.148 meters cubed per second. That's volume per second. So we figured out our volume flow rate for the inflow. Meters cubed per second. Now, the reason this is called the continuity equation is because the water continually flows through the pipe. And the important feature we're now going to use is that the volume flow rate has got to be constant all the way through our pipe. If we have 10 meters cubed of water coming in here every second, we're going to have 10 meters cubed of water coming out every second. Otherwise, the pipe in the middle would have to be expanding or contracting to fit the extra or the less water that's in that space. If our pipe is rigid, then the water coming in and the water coming out have got to be equal. So our volume flow rate of our inflow and our outflow are going to be equal. So I'm going to label that here. Our inflow volume flow rate has got to be equal to our outflow volume flow rate. So we can go ahead and fill in here. This is going to be the same, 0.148. Awesome. So now we have the cross-sectional area of our outflow and we have the volume flow rate because it's the same as of the inflow. So we can now use our continuity equation again to find our outflow velocity. So we have Q equals A times V. We're trying to find velocity, so I'm going to divide by A on both sides so that will cancel on the right. I'm left with velocity is equal to volume flow rate divided by cross-sectional area. So putting in our numbers, our volume flow rate is 0.148. Our cross-sectional area is 0.0951. So our velocity, if we put that in our calculator, is 1.56 meters per second. Awesome, so we found our answer to this question. The velocity of the water emerging from the pipe is 1.56 meters per second. And if we just do a quick check, our inflow had a smaller surface area for the cross-section and a faster velocity. Our outflow has a bigger cross-sectional area, but a slower velocity. That makes sense because the bigger area means a smaller speed is needed for the same volume to pass through in the same length of time. Awesome. Okay, final question. How many minutes will it take to fill a 2,530 meter cubed pond from the outflow? For this, we're going to use our volume flow rate. You can see the units of volume flow rate are meters cubed, which is volume, per second, which is time. So our volume flow rate is our volume over time. So we can use this equation to figure out how many minutes it will take. So we're looking to find the time. So first I'm going to get time on its own in this equation. So I'm going to multiply by time on both sides. That will cancel on the right. Then I'm going to divide by Q on both sides. That will cancel on the left, leaving me with T equals volume divided by volume flow rate. The volume of our pond is 2,530 meters cubed. And our volume flow rate is 0.148 meter cubed per second from the table. So that gives me a time of 17,094 seconds. Now the question asks for the answer in units of minutes. I have it in seconds right now, so I'm going to divide that by 60 to get into minutes. So my time is going to be 17,094 divided by 60, which gets me 284 minutes. So we can go ahead and fill that in our final answer here. Wonderful. Okay. So the most important things when you're doing a continuity equation question is to look at the inflow and the outflow, and remember that the volume flow rate is going to be the same for both. So if you can find both the area and the velocity for one of those ends, you can calculate the volume flow rate for that end. It's going to be the same at the other end, and you can use that as one of your variables to figure out your other unknown.